This episode has been sponsored by Keysight Technologies. Greeting Earthlings! If you follow the channel, you know that we love all things Apollo, and that during our last visit to Steve Jurvetson's amazing space collection, we were given the opportunity to take 2 holy boxes of Apollo electronics to our lab. These are the boxes that brought you voice, data and live TV from the moon and should be early masterpieces of microwave electronics, the blackest of black arts in analog electronics. After gaining a thorough understanding of the amplifier and the transponder, we focused our efforts on powering up the transponder, which we first achieved in the last episode. Everything went well, and we checked that the 3 S-band carriers were transmitted at the right power and frequency. It sure helped that we got our hands on some of the original NASA test equipment. But also quite exciting, so far we have only checked the emission of blank carrier signals from the spacecraft. We have not tried to receive a signal from the ground, nor have we transmitted any information on our resurrected carriers. So the next big milestone would be to receive a signal transmitted from Earth and lock onto it. As we explained in episode 1, this locking mechanism is the linchpin of the whole unified S-band system. If we can do that, the next step forward would be to transmit some modulated tones on each channel. And if that even works, this episode's holy grail would be to demonstrate a round-trip transmission, sending a tone from Earth, getting the spacecraft transponder to lock onto it, turn it around, and send it back to Earth on the translated frequency. Okay, next step, we are going to try to transmit something from the Earth and lock the receiver, because it's a transponder, and it receives the frequency and sends it back so they can measure Doppler. So we should be able to lock one on the other, and this is the original proceedings of the Apollo Unified S-band technical reference from 1965, courtesy of Mike. Found that on
eBay. Yep.
Okay, only Mike can do that. And it tells me the whole procedures of acquisition from the very large antenna they had, and they have all kind of problems because they have to compensate for Doppler shift, but I don't, because I am sitting in my basement here, we're not moving. So I think I need to sweep it 60 kilohertz either way, and it should lock on me. Alright, we'll try that. So I've set myself now, I am honeysuckle, 70-foot dish, and I'm trying to acquire the Apollo spacecraft. And what I'm doing is I am sweeping in frequency, and you can see here, so I am transmitting at 2.1064 something, but I'm starting 60 kilohertz below, and I'm going to go 60 kilohertz above. So that's the transmitted signal. I have to feed it to this, and then we look at the return, and when I turn on my transmitter, see if we can acquire it. So I need to change my frequency over here, because the transponded frequency is this weird 211 over 240 ratio, right? It's what is it again? 2.287. 2.2875 gigahertz. All right, which should be, so now I'm going to turn one on. There it is. It's right here. So now if I put this on and I raise the power, at some point it should jump. That's what I expect if it locks. Right? So here we go. Ooh.
That's interesting.
What's it doing? Am I giving it too much power on 30 dB? And those are huge. I'm interfering with it and not locking it. I can't imagine that I'm exaggerating it with that low. So let's go to amplitude. But I think I have the frequency right, but I don't know if I have the level right. If minus 100 dBm is anywhere close to where it can lock or not. So I should be way above here. So minus 110, I'm in the right range. Okay, we finally locked it. So make the demonstration. I am not sending it anything. I am at 2.0642025 and it's slightly off. And you can start seeing the VCO is responding to it, it's trying to do it, but it can't track. So I'm getting some intermodulation products, probably because we have ranging on and it's trying to turn it around.
Right.
And now I'm going to get closer and closer to the frequency, and I'm going to eventually fall in its locking range. Bonk, locked. So now it locked to me, I'm over here, right? And now I can drag it around. It's totally locked to this one. So now I'm going behind the moon, and I'm going to lose lock. The VCO is drifting a little bit, and bonk, there it goes. Now it's back to its what's called its auxiliary oscillator. Let's see if I can lock it. Yeah, I can lock it directly. No, I'm with. So I just wasn't within the locking band. That's just I was too far off. I had just the wrong impression on how wide the locking band was. It's way narrow. It's a few kilohertz at most. Apollo 13, we have lock. Wow, that's awesome. We could try it on. You want to try it on Transponder too?
Yeah.
See if it does it. There you go. And so it's not very far off. It's using a different oscillator. Oh, did you see that?
Yeah, it was.
When you turn it on, it was using the VCO for a while. Now it's back on this auxiliary oscillator. So now it's locked. Boom, locked. So now I have locked it, right? So I'm going to go back to 364. And I should not lose it. Yeah. So now it's followed me, so I'm back on my nominal frequency. That's if I had zero Doppler, right? Well, PM1 and PM2 do lock. Alright, that was a big step. For the next experiments, we want to hook up everything, so Mike completed his partial test harness. That is the result of your hard work. And we have wired everything. You have wired everything?
I believe so.
All right.
That's
So we should have all the breakouts.
Mm-hmm.
We have this wonderful S meter. Okay, period. Will tell us if we receive any signal, then we can figure out what we put in there. Okay, ready to power the thing, power the big beast with the new wire harness. So if we turn PM1 on, I should receive it. Yes. It is. And we get we get a little weird. It's wearing. So we have transmitted power. Oh, I'm getting transmitted power 212. So that's working. And then the noise you hear is our PM number 1 counter working. We are accumulating new hours. It's really hard to see. So if I give it receive power, I expect to see a little bit on that guy. So we don't have much power at all. Minus 125. You see any?
Nothing on here, but I mean, minus 125 is the bottom of the scale. It should be 0 volts.
Okay, let me see if we can lock it. Well, at least, can you toggle the range thing? See if that disappears or not? Yeah, my theory works. So what we were seeing was the ranging feeding back. Let's see. There you go. So now I can. Right. This is. Well, that didn't take very long to lock. Oh no, it locked.
Oh, look at that.
It did lock. So if I turn it off, unlock, signal is gone. If I give it back some 125, it locks on it immediately. So we're getting better. This indicator is a stand-in for the one that was on the control panel, labeled S-band antenna on this drawing. It gave the astronauts a visual feedback on signal strength, which they could use for manual steering of the high-gain antenna with the two knobs below, or just to check if they had acquired Earth signal. Fantastic! We can receive and lock, and we have the all-important S-band level indicator working too. On the green meter, we also have the static phase error. This is how far detuned the VCO needs to be to achieve lock. This one was not visible to the astronauts, but was transmitted to Earth via telemetry. Same goes for the power indication on the orange meter. By the way, the meter is a gift from our new sponsor, Keysight. You might also have spotted one of their latest oscilloscopes, which will be very useful in our future episodes. We are of course delighted to get support from HP's descendant. Thank you so much, Keysight. So next step would be to transmit a simple tone on each of the carriers, and the unidirectional FM downlink is the simplest one to start with. We've just been able to make a transmission from the moon, which has us very giddy. We'll try to demonstrate for you. It's complicated. So we use the FM channel.
Yep, FM in wideband.
Right, in wideband mode. So right now, if I turn FM on, it should work, right? The noise you hear is the abominable counter. And you can see my FM turns on. And over to the side, I have a frequency modulator here at 440, so it's giving us an A. So if I turn that one on, now it's frequency modulating the signal, not very much actually.
The output from the function generator here is going into the transponder here.
My fantastic connector.
Yeah, Mark's homemade connector.
And I am on the FM data end. So that's the channel they would use for recorded data, usually. And TV, but right now we use it for data. And I can see it coming through, so if I do a max hold, basically it's FM modulated, so it's just modulating between those two frequencies at 400 Hertz. And now I don't have a receiver for this, but I made one up, and I use this mixer. Let's go back into the normal mode here. I'm going to take the output out of the spectrum analyzer, and I am going to put it in my mixer. And here I am going to mix it. I mix it with this frequency out here, which is my local oscillator, which is at 2.29166, which happens to be 20 megahertz higher than 2.27169, and that should give us a signal out that will be the difference and should be now shifted all the way into not baseband but HF. It should be at 20 megahertz. So what you see here is actually the RF that makes it through. But if I go now at, see if I get it back. It's just I have a very large span here. I need 200 kilohertz of span. 200 kilohertz. There we go. So here's my signal again, but it's not at 2 gigahertz anymore. It's at 20 megahertz or something, a little bit lower actually. Where is it? Frequency center. It's at 19.972 megahertz right there. So now I take that signal and I put it into my trusty ham radio receiver put to FM. So if I take that off, and it's tuned to the 19.9 megahertz, and it is our A coming out of the moon. Actually, I'm blasting it with signal, although I took 50 dB off it, just to prove that it's coming from the moon transmitter here. Turn it off. And can make it a 1 kilohertz. Or I can suppress it. So when I suppress it, you see I'm still transmitting, but there's no data. So with that said, we were transmitting from the moon. No, that said all on cable. So if we if we spend a little bit of time, we could have it on antennas. Okay, so we have improved our setup. We do it now over antennas at 2 gigahertz. So we have a Rogue 2.1 gigahertz transmission in the basement. So I think we're fine. And then it's very directive, right? So if we point up, completely up, we don't get it. And then if we point at each other, we'll get it. How much fun can you have with $1 million of equipment? So we know our FM transmitter is working, and the idea is to do the same with the PM transmitter. And I don't have a PM receivers, but PM and FM are related, particularly when it's a continuous tone. I'll detect the cosine wave instead of detecting the sine wave, which should make no difference in the tone. So I think we should be able to transmit a non-encoded signal, although we don't have a PM receiver, and try the same experiment. Let's do it. So we have swapped those two. So now the FM is going to go into the load, and the PM is going to go into the antenna. And then we need to have modulation in. Pull it straight. Yes, up. That's my makeshift connector.
PM1.
There it is. And yeah, 2.875. So it's working. Let me see if I can bring that back to the 20 megahertz band. And for that, I would need to get my local oscillator at 2.307, 2.307 gigahertz. Is it anywhere in the neighborhood? It is not. Yeah, there you go. Here you go. Alright, so that's my baseband signal. Let me try 100 millivolts. And how do we go? Nope, nothing. 1 volt. I should definitely see something. I see a little bit. No. Let me do 10 kilohertz. I know for sure you can do that. Haha! I got it. So this thing is going to crap out at 2 kilohertz or something like that. My ham receiver, because it's made for voice. 2 kilohertz. Oh yeah, I see it. Okay. So that should be a tone. So now, if I receive it, there you go. We're transmitting PM.
Alright.
So now we're going to try the second PM, the redundant channel, right? We have PM2 and it should be exactly the same.
Yeah, no changes to connectors or anything.
Yeah, so our first PM just died. We want to talk to Earth. PM2, and I see it coming here. It's a little bit off in frequency because it's trying the VCO, and poof, now it's doing the free running. It's back in the middle, so if I modulate it, I should modulate it, I receive it. So PM2 is working, we have all our channels working. So the next step is I want to lock it from Earth. So here's Earth, and I am going to try to lock it. So I have disconnected the direct modulation from the spaceship, and I'm modulating Earth. I have to reacquire it. Okay. Locked. Okay. I'm back here. Now I should do ranging on. Right.
Alright.
Do ranging on. Okay. And now I'm going to modulate Earth, and it should turn it around. I have no idea how much I need to modulate it. Oh, perfect. Wow, this is modulated too much. So, volts. Ranging off. There's a little bit that goes through because I'm beating on it like crazy. Oh, helps. Thank you when you do. Helps when you do the ranging, definitely. But it's, when you're not doing ranging, you're supposed not to do that.
Right.
At the transmitter. Okay, well that's pretty good. Everything works so far. Okay, we're trying our next daring experiment. This time we are going to do it all microwave. On the transponder side I have two antennas, one for receive and one for PM retransmit. And I have the same setup over here where I'm transmitting here and receiving here at different frequencies, right? This is going to be turned around. So I'm going to need a little bit more than -125 to lock it, but we're going to see if we can do the whole thing over RF with as moderate a power as I can have. So I shouldn't have to go to anywhere next to detectable levels outside of our lab to do this. Any of the PMs?
Okay, we'll go with
There it is. It came on the screen. I to tune it. Locked it. Bring it back to base frequency. I have it at the receiver. That's it. We're over the air. And I modulate it. There you go. There you have. Yeah. It's better when ranging is on.
Yep.
So we have a we have the bidirectional link basically on two antennas instead of one because we are not triplexing or diplexing. Well, episode's achievement unlocked, we have round-trip transmission. And no, we are absolutely not playing with our very fun pointy logarithmic antennas. Next, we have to rebuild the complex system of subcarriers and make a real PM transmitter and receiver for the Earth side. See you in the next episode! By now the Russians know where we are, or the CIA, so we should turn it off. Alright. There we go. Okay. I think we have played enough. Whoa, that was a lot of equipment.
that is a lot of equipment.